So we've got one final topic or technique here in topic 6.10, and I know this wasn't part of our I can statements or essential question, but this is another one. It doesn't pop up a whole lot, but it's a good one to be aware of. So we're going to add 0 to the numerator, and it really sounds strange that we're going to do that. And it kind of sounds like a little bit of a trick, but sometimes it's an easy way to transform an integrand into something that's more manageable, and therefore we can actually integrate it. So in this first one, and these are things like it would be something you get used to. It hopefully would be something multiple choice. So you would say, hey, it maybe has like a weird natural log or something in the answer. So you have to be able to do something to the function in order to manipulate it to get it to work. So there's two things we can do. We can either multiply by 1 or we can add 0. That's how we can manipulate a function. So I am going to add and subtract e to the x on this one. So I have 1 over e to the x plus 1, and then I'm going to add e to the x, and I'm going to subtract e to the x. So basically, I added 0. I'm going to choose to split up the integral with the same common denominator. So I'm going to go 1 plus e to the x over e to the x plus 1, minus the integral, and dx after it, of e to the x over e to the x plus 1 dx. All right, hopefully you recognize and notice that this is really the same thing as e to the x plus 1 over e to the x plus 1 dx. And that is just, I'm going to put this work up here, is just 1. So I'm integrating 1 dx. And when I integrate 1 dx, I get x. Okay? I'm not writing a plus yet. Then on this back half here, hopefully you're seeing that we have a u substitution going on. So my u is going to be e to the x plus 1, which would make the du e to the x dx. And good news, I have e to the x dx. So it's a very straightforward u substitution problem. So when I go to integrate that, I'm dropping this negative sign down. We have u on the bottom, and for e to the x dx, I'm substituting in du, or 1 du. When I integrate 1 over u, I end up with the natural log of the absolute value of u plus c. And then I'm going to substitute in my u. So my u, when I substitute it in, is e to the x plus 1. All right, let's try one more using this similar technique. So this time we're going to add and subtract a constant that's hopefully going to help us out here. Really what I'm looking for here is anytime I could get a piece of trig, or I can get an arctangent, or I can get a natural log. And likely this problem would be more of the multiple choice style. So this would be, if you saw both like a log and an arctangent log and an arctangent, this might be a technique you would use to get that. So in this case, and again, these just take practice. And if you've seen a few of them, maybe you would kind of remember to do this. So I'm going to keep my original stuff, x squared minus 2x plus 3. I'm noticing that I'm almost at the derivative. I really need 2x minus 2 up there. So I'm kind of going to work from that. I know I need a minus 2, which means I'm going to have another negative 1 up there to get that minus 2. So I'm also going to add 1. And that's where I'm going to get, because that way I'm adding 0. So I'm going to take and split that integral into two separate integrals. So it's going to be 2x, and I'm going to put these guys together. So minus 2 over x squared minus 2x plus 3 dx, plus the integral of 1 over x squared minus 2x plus 3 dx. So let's just work with the front to begin with. So this is going to be my u. So u equals x squared minus 2x plus 3, which means that du equals 2x minus 2 dx. And yay, I have all of that. So a very straightforward u substitution. I am putting in u for the orange, and then for the blue, I've got 1 du. When I integrate that, I get the natural log of the absolute value of u, And then I'm going to substitute in for the u natural log absolute value of x squared minus 2x plus 3. Now I got to deal with the back. The back's not looking so good, so I'm going to try to use maybe completing the square like we just did, because that's about the only thing that might move this a little bit. So I'm going to kind of split it up a little bit. I am going to have the x squared minus 2x piece, and then kind of plus a blank, and then plus 3 plus another blank, and that blank, I think we made it red before. And then at the same time I am doing this, I am also setting up kind of where I put my cheating factoring piece. So x squared plus, and I think we made it pink before. Oh no, it was pink. This was the pink one, huh? That's the pink one. I don't know. I maybe made this red before. All right, and then dx. All right, so I'm going to start by dividing by 2. I'm dividing this by 2 and I get -1. The hint is right here. I take that -1 and I square it. So I'm squaring the -1 and I get 1 in all of those blanks. Okay. So the good news is I'm done. I don't have to really think about it because I kind of already did all the work. So now this is a really straightforward arctangent. So this is the u squared, this is the a squared, meaning that u is equal to x minus 1 and a is equal to 1. So arctangent says that we have 1 over a, so 1 over 1, arctangent of u, which is the x minus 1 over the a, which is 1 plus c. Of course, I did something wrong because 3, okay, I got to fix it. Sorry. I was close, but not quite. The 3, we added 1, so we have to subtract 1, which wouldn't make that plus 1. 1, it would make it a 2. So that means it's going to be the square root, or a is going to be the square root of 2. So we've got square root of 2 and square root of 2 there. So that should end it. And that takes care of all the notes for 6.10.